You know that feeling, right? You're at the cashier trying to figure out your change and your brain just stalls. Mental math can be a real pain, especially subtraction. But what if I told you there's a secret to doing it almost instantly? And that secret comes from an ancient text. Today, we're going to unlock a technique that's so simple, so elegant, it'll completely change how you look at numbers.
First things first, let's identify the enemy. It's that messy, clunky subtraction process we all learned in school. Honestly, it feels like it was designed to be difficult, and it is definitely not built for doing math in your head. But before we get to the fix, let's just feel the pain one last time.
Go on, give it a shot. In your head, what's 10,000 minus 7,853? No pen, no paper. You can feel your brain starting to grind the gears, can't you? You're picturing all those zeros, and you just know you're in for a world of borrowing. It's a hassle.
Yeah, see, the way we're taught forces us to work from right to left. You try to subtract the 3 from a 0, which you can't do, so you have to go next door to borrow. But that's a 0 too, and so is the next one. You have to go all the way over to the 1, borrow from it, carry it over, and by the time you're done, you've completely lost your train of thought. There just has to be a better way.
And of course there is. The solution comes from a system known as Vedic Mathematics. It's all based on these incredibly powerful and graceful rules called sutras. And these are just little tricks. They're deep insights into the very nature of numbers. The one we're going to look at today is the key to making subtraction practically effortless. And here it is. Nikhilum navataha charmam dashtaha. Now, don't worry about the Sanskrit. Just think of it like a secret code, an ancient piece of software for your brain that we're about to install.
And the translation is just beautifully simple. All from 9 and the last from 10. That one sentence. That's the entire instruction. This rule is our new tool, and its main job is to help us find something called a deficit. Let me show you what I mean.
So, before we can fix subtraction, we have to get good at using this new tool. We're going to practice finding a numbers deficit using our new mantra. All from 9 and the last from 10.
So what exactly is a deficit? Well, it's just the number you need to add to get to the next big round power of 10. So for a number like 7, the deficit is 3, because 7 plus 3 gets you to 10. For 98, the deficit is 2, because 98 plus 2 gets you to 100. It's sometimes called the tens complement. Now let's use the sutra to find it instantly.
Let's find the deficit for 7,853 using our rule. We're going to subtract every digit from 9 except for the very last one. That last one we subtract from 10. And we go from left to right. So 9 minus 7 is 2. 9 minus 8 is 1. 9 minus 5 is 4. And then for the last digit, 10 minus 3 is 7. Boom! The deficit is 2,147.
Whoa, did you catch that? The most important part? We did it from left to right. This is the absolute game changer. Unlike that clunky borrowing method, you can literally just say the answer out loud as you figure it out. 2, 1, 4, 7. It makes doing it in your head incredibly fast and just natural.
Okay, so you might be thinking, what about numbers that end in 0, like 48,000? The rule handles this beautifully. You just apply all from 9, last from 10, to the part of the number with actual digits. So the last non-zero digit is the key. For 48,000, that's the 8. So 9 minus 4 is 5. And since 8 is the last one here, we do 10 minus 8, which is 2. And the zeros on the end, they just tag along for the ride. The deficit of 48,000 is 52,000. It just works.
All right, your turn. Let's do a quick practice run. What's the deficit of 3,275? Remember the rule, all from 9, last from 10, go from left to right. I'll give you a second. Okay, you got it? It's 9 minus 3 is 6, 9 minus 2 is 7, 9 minus 7 is 2, and the last one, 10 minus 5 is 5. The answer is 6,725. See, it's almost too easy.
Okay, so you've learned the secret handshake. You've mastered the tool. Now it's time for the main event. We are ready to go back to that original problem and make subtraction simple. This is that aha moment where it all comes together.
The whole method boils down to just 3 simple steps. First, you find the deficit of the number you're trying to subtract. We just learned how to do that. Second, instead of subtracting, you add that deficit to the original number. And third, you just chop off the leading one from your answer. And that's it. You've turned subtraction into addition.
Let's see it in action. Let's try to solve 8,232 minus 6,897. The old way? Ugh, you're already getting a headache just thinking about all the borrowing. Now, the Vedic way. Step 1, find the deficit of 6,897. Using our rule, we get 3,103. Step 2, add it. 8,232 plus 3,103 is 11,335. Step 3, drop the leading 1. The answer is 1,335. No borrowing, no mess, just clean, simple, and incredibly fast.
So at this point, you're probably thinking this is some kind of black magic, right? A math cheat code. But it's not magic at all. It's actually built on a really solid and, frankly, very clever mathematical principle.
So here's the logic, and it's actually really simple. Subtracting a number, let's call it b, from another number, a, is mathematically the exact same thing as taking a, adding the deficit of b, and then subtracting the base, like 10,000. That base minus b part, that is the deficit we find using our sutra. So when we added 8,232 plus 3,103, we get 11,335. That number is just our real answer plus the base of 10,000. So subtracting the base is literally as simple as ignoring that leading 1. It's an amazing algebraic shortcut.
And that really brings us to a final thought here. We just took a single ancient phrase and used it to turn a really clumsy process into something elegant and lightning fast. And it just makes you wonder, right? If something this powerful was just hiding there in plain sight, what other incredible secrets about math, about the way the world works, have we forgotten? What else is out there, just waiting to be rediscovered?